Elementary transformation. There are two types of elementary transformation. One is elementary row transformation and one is elementary column transformation. But the rules are the same for both of these transformations. These are the three rules which we're going to discuss how this elementary transformation actually works. First one is the interchanging two rows or columns, which means for a 2 cross 2 matrix, we can write it as row 1 can interchange with row 2 because 2 cross 2 matrix has only two rows. Similarly, column 1 can interchange with column 2 because this matrix has only two columns. And for a 3 cross 3 matrix, we can write it as row 1 can interchange with row 2 or row 2 can interchange with row 3 and also row 3 can interchange with row 1. Similarly, it goes with the columns also. The second rule is multiplying all elements of a row or a column by a non-zero scalar, which means any row can be changed as a scalar multiplied with the same row. K is a scalar quantity over here. It's nothing but a constant. Similarly, column can be changed as when scalar multiplied with the same column entries. The third one, adding to the elements of a row or a column, the corresponding elements of any other row or column multiplies by a scalar, which looks something complicated, right? So let's take an example. Like if there is a 2 cross 2 matrix, we can write it as row 1 can be changed as row 1 plus scalar multiplied with its corresponding elements of the other row. Sorry, it's row 2, corresponding elements of the other row. Similarly, we can write it as column, like second column can be changed as column 2 plus any scalar quantity multiplied with its corresponding other column. Okay. Similarly, you can write it for its 3 cross 3 matrix. Like row 3 can be changed as row 3 plus or minus also we can do it. Plus and it's any scalar like 4. It's a scalar quantity multiplied with its corresponding elements of the first row. Similarly, column we can write it as column 1 can be changed as column 1 plus 7 into column 3. It's like that. So you might get a question key why where is this elementary transformation is used. So this kind of transformations or this concept is used to find out the inverse of a matrix. So I'm going to discuss elementary row transformation and elementary column transformation in detail by taking few examples, and through these examples we can have a clear idea ki how to find the inverse of a matrix.